Hello everyone, welcome back to my channel. This is a series on machine learning from basic to advanced. In our last video, we discussed supervised learning. We described what is supervised learning, some basic definitions, and we categorized supervised learning into two broader categories: regression analysis and classification. So regression are the models which predict continuous variable, and in classification you predict qualitative or categories. In this video, we discuss regression models. Particularly, we will be discussing linear regression. Linear regression is one of the most fundamental and widely used technique in statistics and machine learning. It's a method which captures the linear relationship between the input variable x and the output variable y. Linear regression was largely developed at the pre-computer age. But even in today's computer era, there are still so many good reasons why we should still study them. Because they are simple and they provide adequate and interpretable descriptions of how input affects the output. In most of the cases, these linear models can outperform complex non-linear models. So for example, when you have small number of training cases, low signal to noise ratio, and sparse data. In its simplest form, we are trying to find the straight line which describes the linear relationship between the input and the output. The basic equation looks like this. Let's break this down. Beta naught is our intercept where our line crosses the y-axis. Each beta I represents how much our prediction changes when we change the corresponding xi by 1 unit. The xi values are our input features. So what makes linear regression particularly powerful is its flexibility in dealing with different kinds of input. For example, we can use several different types, and I describe them here. We can either use numerical measurements, things like age or temperature readings. We can also use transformed variables. Sometimes the relationship is not linear in the original scale, but becomes linear after transformation. Then we can also have categorical information in our model. Input can also take a form of interaction terms. Sometimes the effect of one variable depends on another. So these are the assumptions that you should check before you apply the modeling. The first is the linearity. It assumes a linear relationship between the input and the output. The second assumption is the independence of error. The third assumption of linear regression is the constant variance of errors. The fourth assumption is multicollinearity. The fifth assumption is the normality of error. For hypothesis testing and confidence intervals, assume residuals are normally distributed around 0. So these are the main assumptions of the linear regression model, which are very important to check before you apply the modeling. In this video, we discuss the basics of linear regression, and we also discuss the assumptions behind the linear regression model. I hope you understand the basics. In our next video, we will discuss more advanced topics. We will see how we can estimate these parameters beta using the least square estimation method. We will also see how to understand and calculate the variance of these parameters and understand the underlying distribution of these parameters. We will see how to build the confidence interval, how to do the hypothesis testing. If you like this video and learned something new, please give it a like and subscribe to my channel for more videos. Share this video with your friends and family, and I will see you in the next video. Until then, take care and bye.